Hi, and welcome to another Dante tutorial. This time, I'll be walking you through how to create a full nitriding simulation with ANSYS. This includes a nitriding model, a thermal model, and a stress model. For this tutorial, I'll be using a ring slice geometry that'll be provided in the description. You can also find it within the Dante files. To start, open the ANSYS workbench. Click Extensions, and then Manage Extensions. And in the Extension Manager, make sure DANTE Act is clicked. It is critical that the units be properly defined. Select Units in the Unit Systems. Make sure that Metric with kilograms is selected. Drag and drop a mechanical model from the component systems into the project schematic. Rename it Sliced Ring Model. Let's import the geometry. Right-click Geometry, and then Import Geometry and Browse. Open the Sliced Ring Nitrided XT file provided, and then double-click Model to open ANSYS Mechanical. Make sure the units are correct before continuing. Now I'm going to define the surface for meshing. Click Face Selection and select the outer surface. Right-click and create a name section, naming it Outer Surface and clicking OK. Select Mesh in the project tree, and we're going to modify the details of the mesh using this table. Right-click Mesh and then Generate Mesh. Once the mesh is finished generating, close ANSYS Mechanical and save your project. To start creating the nitriding model, drag and drop a transient thermal analysis system into the project schematic. Rename it Nitriding Model. Drag and drop the model from the sliced ring model to the nitriding model. Right-click Model and then click Update, and then double-click Model to open up ANSYS Mechanical. Again, it is critical that units are properly defined, so click on Units in the Home toolbar and make sure that the correct units are selected. Go to the Dante toolbar and select Dante Model and then Nitriding. Click Initial Temperature in the project tree and set 0 for the initial temperature. Now let's define the processing steps. Select Analysis Settings in the project tree and enter the following information into the details of analysis settings. Select Material from the Dante toolbar, and in the Details of Material, click on the yellow box next to Geometry and select the part body and select Apply. Select the material name, which we will use SH13XX. Now add a nitriding temperature from the Dante toolbar and click the tabular data. Add 2 rows to the table and input 525 degrees Celsius as the constant for 36,000 seconds and click Apply. Add a model control from the DANTE toolbar. Now select Output Frequency from the DANTE toolbar. Click the tabular data, and for this tutorial, I'll keep the data as default and click Apply. Next, I'm going to define the nitriding boundary condition. Select Convection from the Environment toolbar and set the scoping method to name selection and the name selection to the outer surface we created earlier. Set the film coefficient to 0.0005 and the ambient temperature to 0.009. Next, click Finalize Model Settings from the DANTE toolbar, and then right-click Solution and Solve. To view your results, go under DANTE Results and select Nitrogen All, then right-click it and evaluate all results. You may notice that the mesh on the nitriding model will be noticeably finer than the thermal or stress models. This is needed to view the very thin layer of nitrides that are formed. Before we can move on, we need to export the nitrogen profile. Select Write Nitrogen Profile from the DANTE toolbar, and under the details, you should change the file name to something you'll recognize. I'll name mine DANTE Nitriding Tutorial. Right-click Write Nitrogen Profile, and then evaluate all results. The nitrogen profile should be saved as an NTD file under DANTE Files. Once you've done this, we can close ANSYS Mechanical and save our project. Now let's move on to the thermal model. Drag and drop a transient thermal analysis system into the project schematic and rename it thermal model. Drag and drop the model from the sliced ring model to the model inside the thermal model, and then double-click Model to open up ANSYS Mechanical. Again, make sure the proper units are selected. Click on the DANTE model in the DANTE toolbar and select Thermal. Select Initial Temperature in the project tree, and we're going to change the initial temperature value to 20 degrees Celsius. Next, go to the Analysis settings and enter 3 for the number of steps. Working backwards, enter this table of information into the details. It is critical to work from the last step backwards for this to work properly. Next, let's add the material. Select Material from the DANTE toolbar and click the yellow box next to Geometry, selecting the part body. select Apply. Select SH13XX for the material name and enter 0.004 for the total carbon. Click the tabular data for material initial phase and set tempered martensite to 1 with other phases setting to 0. Add a model control from the DANTE toolbar. Set the default phase transform kinetics mode to -7 rate dependent. Click tabular data and leave the information as default and click Apply. Select output frequency from the DANTE toolbar and click on tabular data. Leave the default frequency values as 2 and click Apply. Next, I'm going to import the nitrogen profile that we created earlier. Select CN profile from the DANTE toolbar and set the number of nitriding profiles to 1. Click Nitriding File and navigate to the DANTE files and select the previously created nitrogen profile and click Open. Under Carburization/Nitriding Activation table, click the tabular data. Set nitriding to 1 as step 2 to activate it and click Apply. Next, I'll add the thermal boundary conditions. Add 2 convections from the Environment toolbar to the project tree, and then right-click the convections and rename them to Heating and Quenching. Select Heating and set Scoping Method to Name Selection and the Name Selection to Outer Surface. Set Film Coefficient to 0.0001 and set the ambient temperature to 525 degrees Celsius. In the tabular data, right-click row 4 or the last row and select Activate/Deactivate this step. Next, select Quench and similarly set the scoping method to name selection and the name selection to outer surface. Set the film coefficient to 0.0001 and the ambient temperature to 20 degrees Celsius. In the tabular data, right-click and highlight all rows except for the last row and activate/deactivate those steps. Now, I'll finalize the model by selecting Finalize Model Settings in the DANTE toolbar, saving the model, then right-clicking Solution and Solving. Once the model is done running, under DANTE Results, select Total Hardness, and then right-click Total Hardness and evaluate all results. Close ANSYS Mechanical and save your project. Now let's set up the stress model. Drag and drop a static structural analysis system into the project schematic and rename it Stress Model. Drag and drop the model from the slice ring model to the stress model. Drag and drop the solution from the nitriding thermal model to the setup of the nitriding stress model. Right-click Setup and Solution and update both. Double-click Setup in the nitriding stress model. Make sure the correct units are selected. Click on the Dante model in the Dante toolbar and select Stress. Click on Static Structural in the project tree and change the environment temperature to 20 degrees Celsius. To define the processing steps, select Analysis Settings and enter 3 for number of steps. Enter the following information, making sure to start from step 3, the last step, and working backwards. Next, to assign the material, select Material from the Dante toolbar and click on the yellow box next to Geometry, selecting the part Body. Select SH13XX again as the material and enter 0.004 for the total carbon. Click Tabular Data for the material initial phase and set everything to 0 except for tempered martensite, which should be set to 1. Next, add a model control from the Dante toolbar. Set the default phase transformation kinetics mode to -7 and click Tabular Data for the kinetics mode table and then click Apply. Next, add an output frequency from the Dante toolbar and in the details, click the Tabular Data. Leave the default frequency values as 10 and click Apply. Now, let's once again import the nitrogen profile. Select CN Profile from the Dante toolbar and set the number of nitriding profiles to 1. Click Nitriding File and navigate to the Dante Files and select the previously made nitrogen profile. Click Open. Under Carburization/Nitriding Deactivation table, click Tabular Data and set nitriding to 1 at step 2 to activate it and click Apply. Now I'm going to import the thermal history. Expand imported load in the project tree. Select imported body temperature and set the source time to all, and then right click the imported body temperature and then select import load. Now I'm going to define the mechanical boundary conditions. From the environment toolbar, add a frictionless support and a displacement to the project tree. Click on the details of frictionless support and click the yellow box next to geometry. Select the 2 internal faces of the ring while holding Control and then click Apply. Next, select Displacement and click the yellow box next to Geometry. Select the bottom inner vertex and click Apply. In the details of displacement, also set the Y component to 0. Now the stress model is ready to run. Select Finalize Model Settings in the Dante toolbar, save the model, and then right-click Solution and Solve. Once the model is done running, right-click Solution in the project tree and then select Insert, Stress, and Normal. In the details of normal stress, select the Y-axis signifying axial stress. Right-click on normal stress and select Evaluate all results. And that concludes another Dante tutorial. If you have any questions or you have something you want to simulate, feel free to comment down below or send us a message at support@dantesolutions.com. Thank you for watching and happy simulating.